Americans love science. Shows like the new Cosmos with Neil deGrasse Tyson are always popular, as was the earlier version of the show with scientist Carl Sagan. We watch Nova and Nature on PBS, and the science-themed shows on Discovery Network are always fascinating. Among the most interesting of the shows are those that look back at scientific history. It's amazing that ancient Greeks and others could even do science back in those days without telescopes, microscopes, or even much of the mathematics we have now. Yet the men and women who make amazing scientific discoveries today do so by standing on the shoulders of those scientists and thinkers who came before. That's the idea of the Ponderables series of books.
That's what we try to do in the Ponderables series. We break the subject, in this case physics, down into 100 steps. We start way back in the past, in ancient Greek times generally, and then you see how the modern understanding of physics arose out of the work of 100 people who built on each other's discoveries.
That's Tom Jackson, author of the Ponderables book titled Physics, An Illustrated History of the Foundations of Science. It's a tall order to choose only 100 people out of the entire pantheon of scientists who contributed to physics.
There is a set of ideas that I wanted to be able to explain for the readers so they'd understand the basics behind things like electricity and force and particle physics and quantum physics, introducing them all to those subjects. So I chose the figures that led towards those end points. So in the later part of the book where we're getting into modern times, the reader has a full idea of those subjects. So it was a question of choosing the people who did the important stuff. Fortunately, of course, a lot of people who feature in the book worked in all of the important areas, so you could cover lots of different subjects at once.
The first person featured in the book is an ancient Greek philosopher named Thales, who lived in the 7th century BC. But how could anyone know about physics that far into the past?
Well, physics just means nature in ancient Greek. It was the study of nature. And the interesting thing about Thales was that he wasn't going to take anyone else's word for it. He wanted to explain things, have reasons for things that he could see the evidence for. He's the first person we know who behaved in that way, and that's why he's described as the father of science. He didn't know a great deal about physics, but he sort of set the ball rolling.
Observing things firsthand was an important step in discovering how the world worked. So was thinking about how natural elements behave, even if you couldn't see them, by using thought experiments, the way Leucippus did back in the 5th century BC when he developed a theory of atoms.
Leucippus proposed that there were units in matter that couldn't be divided in half, that were uncuttable. Atoms means uncuttable in Greek, and that once you got down to this unit, it was impossible to break it down any smaller.
Some of the biggest scientific discoveries came during the Renaissance by names that we're all familiar with: Copernicus, Kepler, and Galileo. Jackson says that Copernicus and Galileo documented some of the same astronomical events, such as determining that our solar system didn't revolve around the Earth, but around the Sun. But Copernicus was cautious not to step on the toes of the very politically powerful Catholic Church by spreading his theories. Galileo wasn't.
He was the first one to contradict the Church on scientific grounds while he was alive, really. Copernicus knew well enough not to do it. He'd come 30 or 40 years before. He knew well enough not to do it until he died. So he didn't publish his book until he was on his deathbed, and he died about a week later. So they weren't going to do anything to him. What Galileo had done was he'd contradicted Aristotle. So the Catholic Church had kind of given Aristotle a sort of a semi-prophet status because he predated Christ. They assumed that in some way they'd gone through some rather convoluted thought processes to say that what Aristotle said was also what God said about the universe. And so it was fine. You could follow science as long as all you were doing was just reformulating Aristotle's work to better describe the universe. But if you do what Copernicus did and then Galileo did and said that Aristotle had got it all wrong, that's when you got in trouble.
Jackson is quick to point out that religion didn't always get in the way of scientific discoveries. In fact, in the Middle East, it was a driving force behind them.
One of the central tenets of Islam is to read and to study and to learn. And a lot of the traditions that we associate with Western science, the rigor and the empiricism, measuring things carefully and recording your findings so they can be shared, comes from the Islamic tradition, and then that comes into Europe during the Renaissance. Before then, scientists in Europe were very much almost sort of wizardy people. They kept it all very quiet and they were in their layers.
How did someone back in, say, Isaac Newton's time become a scientist? Were there university courses of study? Jackson says that although there were universities at the time, they didn't have degree programs in physics. Scientists came from the ranks of well-to-do gentlemen who had private incomes and a talent for science. They did, however, form organizations where they debated theories and published papers.
The scientific revolution of the 17th century were people like Robert Hooke and Isaac Newton and René Descartes and people like that. Some of them worked at universities, like Newton worked at Cambridge University, and he was a math professor. But most of them formed these informal groups. They would meet and have discussions and learn from each other and disseminate information and frequently steal it from each other and then argue about it afterwards. And those traditions come from France and London, from Paris and London around the same time in the 1660s. They formed academies of science that came out of the informal gatherings, and they became these formal bodies which would disseminate science and publish journals. And from that point on, to be a scientist meant that you had to be associated with these groups and get your discovery printed in their journal and discussed at their meetings, and hopefully you'd become a member yourself.
Marie Curie is the only woman featured in the book. But it's not surprising. Jackson says that back in the 1800s, there just weren't many women who studied science at the highest levels. Curie was one of the exceptions. She found a place at the University of Paris and worked hard to scrape the money together to pay her tuition. And it was in Paris where she met her husband, Pierre,
who was a slightly older and already established scientist. And then the two of them became leading figures in the field of radioactivity, which had only been discovered a couple of years before. Marie had the talent and the perseverance and the luck to become famous and to make great discoveries that ultimately killed her, actually. But the radiation that she worked with ultimately killed her. She died from leukemia.
She was the first woman to win 2 Nobel Prizes, one in physics and one in chemistry, and only one of 2 people to win in 2 different fields. During the 20th century, discoveries in physics came fast and furiously. Perhaps the most famous physicist of the last century is theoretical physicist Albert Einstein with his theory of special relativity. Jackson says that it's thought that most discoveries in physics will be made, if not by the scientists who became famous for them, then by someone else shortly afterward. Einstein's relativity theory, though, was something altogether different.
Famous scientists that you can think of are just the lucky ones who were in the right place at the right time. If it wasn't them, then maybe a year or 2 later, the conditions were such that someone else would make that discovery. But what they say about Einstein is that maybe even today, if Einstein hadn't made his discovery just over 100 years ago, it was such an amazing leap of imagination that maybe even today we still wouldn't have that theory, and physics would have taken a very different course.
Author Tom Jackson invites you to read more about Einstein's contributions, along with those by scientists from ancient Greece to the present day, in the ponderable series book, Physics, An Illustrated History of the Foundations of Science, available in stores and online. You can find out more about all of our guests on our website at viewpointsonline.net. I'm Gary Price.
For the first time in nearly 30 years, boxing is back on free primetime TV. NBC and Spike will give fans a ringside seat to the top fights in the sport starting Saturday night, March 7th at 9 p.m. Eastern Time on NBC, when Cincinnati's Adrian the Problem Bronner faces off against LA's John Molina, and Keith One-Time Thurman slugs it out with Robert the Ghost Guerrero. Then Saturday night, March 13th on Spike, Andre Berto battles Joséito Lopez, and Sean Showtime Porter goes against Roberto La Amenza Garcia. It's the debut of the Premier Boxing Champions Series on NBC and Spike, featuring today's brightest boxing stars in their most thrilling matches. Premier Boxing Champions matches will air Fridays and Saturdays on NBC, NBCSN, and Spike. The primetime NBC fights will feature broadcasting legends Al Michaels and Marv Albert, while Spike fights will be hosted by Dana Jacobson and Scott Hansen. So pull up a seat, tune in, and get ready for more than 50 hours of Premier Boxing coverage on free TV, all starting on March 7th at 9 p.m. Eastern Time on NBC.
Geico presents Fan Mail to a Pig.
Dear Maxwell, first off, hope you are well. And I am. Seems like all you do is promote Geico's web and app abilities. And while I really enjoyed your last commercial where you talked about how I could take a photo of my VIN number and add it to my account all via my Geico app, I've got to think it doesn't leave you much time for anything else. Do tell. Sincerely, Miranda Morgan. Well, Miranda, thank you for asking. And this Geico spokespig does have time to do other things. For instance, I do a lot of...
VIN scanning to add a car, just a tap away on the Geico app.
You hear that, kid? That's the hum of a well-run facility. You know what I hate hearing? Silence. Silence on a production line means downtime. Downtime means wasted time. Wasted time means wasted money. Silence isn't golden, kid. It's deadly. That's why I love Grainger. With a wide variety of the latest products, Grainger gets us what we need when we need it to help keep this place up and running and humming away. Get it? Got it? Good. Call, click Grainger.com or stop by. Grainger, for the ones who get it done.